The scale, here it is. You need to decide an appropriate scale. And a scale, you saw it's a graph paper. Okay? And on a graph paper, sometimes you might draw data that is really huge that cannot just fit on a graph paper. And I usually illustrate it with this. In geography, you draw maps, map of Uganda, map of East Africa, map of Africa. Africa is large. Too big, too big, too big, too big, too big. But you find ways of fitting it on a paper. So you reduce it to the extent of it fitting on a paper. So that unit of reducing becomes a scale. Okay? You cannot put the whole of Africa the way it is on a paper, no. But you try to reduce until when it fits on a paper. So that becomes a scale. So now you need to decide an appropriate scale that will make your graph to be as large as possible to cover 3/4 of the paper. For instance, if this is your paper, okay, and you draw such a graph, man, you can see. I'll be like, now what is this? What's this? What is the whole of this space for? Is it mine? So it's your scale that will either make your graph appear large enough or to appear as tiny as nothing. It's your scale. Now, how are you going to choose a scale that is really good, that will make your graph appear good? We determine the scale from the highest and the lowest value from the data that is provided. I guess we have some data here. And even if we don't, we shall simply, you get the highest, okay, minus the lowest, basing on the values given. And then you divide by the number of boxes that you want your graph to cover. Whereby, now usually normal graph papers, they usually have 8 on the horizontal axis and they usually have 10 on the vertical axis. But if you want your graph to simply cover 4, then you divide by 4. If you want your graph to cover 5 here, you simply get the highest minus the lowest, divide by the number of boxes, which is probably 5. If you want your graph to be big enough, then you divide by the entire 8 and you divide by 10. Now you get, after this, you get some confusing value. You get some huge value. Maybe you might get 0.333. You might get 0.4767. You might get 47 as your answer. You might get 76 as you get any value. Now this is for me. This is how, because I've interacted a lot, I've plotted enough graphs, this is what I've discovered. Now the value that you get, first of all, before the value, if you want to easily plot a good graph that you can easily find the values to plot, your scale, this one, the range from one value to another value, we call it a range. It should either be in ones, that is multiples of ones, that is to say 1, 2, 3, 4, 5, 6, and so on. Or it should be, the range should be in multiples of 2. That's why you're going to write 2, and then you write 4, and then you write 6, and then you write 8, you write 10. Or in multiples of 5. Okay? That is, say, 5, 10, 15, 20, and so on. Now, anything away from this, your graph is going to be ambiguous, that it will be so hard to locate a given value. For example, let's say you've used the scale of 3. Where are you going to plot 7? How easily are you going to find 7? It's really hard to find a 7 on such a scale. But if you use a scale of maybe 1, you easily find 7. It will even be there. If you use a scale of 2, the 7 will be between 6 and 8. And you can easily locate the 7. If you use a scale of 5, 5, 10, it means these are the values. There will be 6, 7, 8, 9, 10. You can easily locate the 7. So always the values you write here, they should be in multiples of 1 to 5. Now, why am I saying 1 to 5? Depending on your data, it will determine this value here. If the data is in 0 point something, 0 0.01, 0 0.02, 0 0.05, then these values you are going to use, they should also be in 0 points. If it's 2, then it will be 0 0.02, 0 0.04, 0 0.06, and so on. If you've decided to use 5, then it will be 0 0.05, 0 0.1, 0 0.15, and so on. So it's your data that you have is the one that will give you how these values are going to be written on the scale. But the key concept is the range should be either 1 or 2 or 5. If the data is in thousands, maybe you have 2,400, 2,054, whatever, and then 2,456, 2,000. Then these values, if you decide to use 1, then it should be also in thousands. That's why it be 1,000, 2,000, and then 3,000. Sorry for that. So this data should be also, if you decide to use 5, yes, it will also be in 5,000, and then you go to 10,000, 15K, and so on. But the scale must be either 1 or 2, 5. Now, when you divide your highest minus lowest, you won't get the 1, you won't get the 2, you won't get the 5. You won't get the 0.2, the 0.5, the 0.1. No. But you get such an ambiguous value, a confusing value. So then, what do you have to do? What the hell do you have to do about it? We shall simply truncate. I think I'm still looking for the better word to use. It is not rounding off, it's not truncating. But we simply use any of these values, 1, 2, or 5, that is close to the value that you have gotten. But the value shouldn't be below the value that you've gotten. What am I trying to talk about? If you get 0.333 recurring, you have a chance to use 0.1 or 0.2 or 0.5. Now, 0.33 is above 0.1, so you cannot use that 0.1. 0.33 is above 0.2. We cannot use 0.2 as our scale. And 0.33 is just below 0.5. So therefore here we shall use 0.5. Similarly with 0.47, you will still use 0.5. Now if you use 0.5, you will write 0.5, then 1, 1.5, and the highest value will be covered. But you dare use a value that is below the value that you've gotten here. You reach the maximum box and the highest value will not be covered. And you'll need to add another graph paper. I don't know how you do that. Let's say you've gotten this. You've gotten your 0.7545. After dividing highest minus lowest, divide by number of boxes that you want your graph to cover. Now, you either use, we have 0.1, 0.2, and 0.5, okay? And next to this, it's 1, it's 2, and it's 5. Now, you cannot use 0.1 because it is far, far smaller than this. Neither can you use 0.2 because it is far, far, far smaller than this. And still the 0.5 is also smaller than the 0.75. The answer that you've gotten when you divided highest minus lowest, the difference when you divided it by number of boxes. So therefore, what shall we do? We shall simply go to the next value. Okay? And if 0.75, the next value is simply 1. So your scale is going to be in ones. 1, 2, 3, 4, 5, 6, 7, and so on. Not so? Yes. And so for such a data, you can have a look. Can you get a scale for carbon dioxide concentration in ppm? And by the way, it is not a must that you should begin from 0. It's not a must. A graph can begin with any value as long as you've followed the right procedure. As long as you've presented it right. It can begin with 344, and then you go to 346, and then you go to 348. It is okay. And then for this one, it can begin from 0. It is okay. Don't be confused. It is okay for a graph not to begin from 0. So what's your highest minus lowest here? What will be your scale that you use to plot these two values? The carbon dioxide concentration, for example. You get to that one. You pause and get that one. Yes, so guys, that was good. So when I divided, I got, let me use red. Somebody told me that they gotten for this 1000, then minus 350, and they got 650 as their highest minus lowest, and then divide by number of boxes, and they divided it by 18. I think they considered 1, 2 on a graph paper. That one is okay. And so they got 36.11 recurring. Now the 36.11 recurring, it is we either use 10, or we use 20, or we use 50. Okay? But this is above 10, it's above 20, but it's simply below 50. So we shall use the 50. So it will be 50, and then 100, okay, and then 150, and so on. Then another student they used this. After 650, they divided by 8 and they got, was it 81 point something? 81.25. And the answer was, yes, 81.25. Now 81.25, it is way above 50, so you cannot use 50 for this scale. So we should use the 100 as our scale. Okay? And the difference, all of them did the same thing, but the difference is the one of 18 counted this small box, this 1 centimeter, and they are going to have to write 50 here, 100, and so on, 150, and so on. Then another one of 8, for them they counted 1, 2, 3, and so on. So this one is going to write the 100 here, okay, and then the 200. And in actual sense, you can actually see that you all have the same thing. And so when all of you are reporting your graph, it is strictly 1 centimeter. Whether you've used 1 centimeter like this one, or whether you've used the 2 centimeters like this one, it is strictly 1 centimeter. So you will say 1 centimeter represents. Now for this person, for him, he's okay, he has used 1 centimeter. So you simply write the difference, the difference, the difference, and the difference must be the same. And that difference is your scale. So you say 1 centimeter represents 50 ppm. Okay? 50 parts per million. As simple as that. But for this one, who has used the 2 centimeters, you can't say 2 centimeters represent. That is wrong. Shall cross you. You have to use 1 centimeter represents. Okay? And then you divide. If this is 100, then what does 1 represent? It is simply 100 divided by the 2 centimeters, which is 50. So you still write 50 ppm. So do you see that actually all of you guys have one scale? Yes. So after writing your scale, you have your title, access variable. The next thing is plotting. And plotting, you just plot values given, whereby you either use X, just use X, let me clean. You go here, and then you go here, and you see where the 2 points meet, and you draw there an X. Don't draw these lines, okay? Don't draw those lines. It is simply X, and then another X, another X. Or alternatively, if X is hard for you, or if you don't want it, just write a dot. It's a dot, not this, not this. Simply a dot. And because you want us to see where the point is, then you emphasize that point by ringing it. Then you do the same dot, okay, and you ring the dot. You do the same dot and you ring the dot. You do the same dot and you ring the dot. And then after you join these points, and joining you use a free hand with a sharp pencil. The same applies here, free hand. And if there are more than one variable, then that's when you say X, you will name. Don't use dotted lines. Don't do this. No, this is wrong. Just draw one solid line and you name. Maybe this is the corn plant. You write corn plant. And then you do the same. You write velvet leaf plant. Not so? Valvate leaf plant. Don't draw. Even when you are plotting, you can, if you decide to use X, then use X for both. If you decide to use this, then use it for both and you label. And make sure the curve doesn't cross the label line. Don't draw one curve. Actually, first draw one curve and wait to label. Join points, wait. And then you draw another one, you join points, and then you label. So that these curves don't cross the label lines. The label lines don't cross the curve. So if you do that, it will really be good for you. Yeah, somebody has a concern. If you are labeling, okay, maybe you have this curve and then you have another curve. Now, you are not supposed to use arrows. That if you use arrows, it's as if this is a branch of this curve. This one is also another branch of this curve. And yeah, that one makes sense. So it's better you draw next to that line. If this one, you write dry mass, you just write cone plant. Cone plant. We shall know that this one is a cone plant. And then you write the valvate leaf plant. So, in other words, you need to be as careful as possible. That one is okay. That one makes more sense. Any other concern? Okay, that's good. So you guys, you're going to try out this question, and we studied this in homeostasis. You are given this, you read through, you can pause and read through, and then you present your data, you describe the activity, and then you deduce. However, we shall discuss how to describe in our next lesson. But go and plot this and do more, so that plotting really becomes part of it.